Chapter 6 deals with attribute data. Often, after adding a new field, you need to edit or calculate values for the field. One way to edit a table data is to use an editing session. You would open the Editor toolbar, start editing, and when finished, save and stop editing. This method will allow you to adjust any of the field values. Again, when you add a new field, be sure to get the field type correct. Do you need a decimal place? If yes, then you can't use short or long integers. You must use float or double. Using the field calculator is another way to edit table values. The field calculator will only manipulate the selected field, and if records are selected, it will only manipulate those selected records. The field calculator is a powerful tool capable of making simple or complex calculations or expressions. You can even save your expressions to use again and again. Shape area and shape length fields are automatically created and updated for geodatabase features. Know that the unit of measure will match that of the coordinate system. Shapefile geometry fields must be created and updated manually. If you find an area field, there's no way to guarantee it's correct. You should create and calculate your own when you need it. When working with shapefiles, the area, length, and perimeter fields do not update when the features are changed. Calculating geometry is a valuable tool. This is helpful when you want to know the length of lines or area of polygons. You can specify your output unit of measures. From a table, we can quickly analyze the statistics of a particular field of all the records or selected records. A little review here. Ask yourself these questions. A field name area in a shapefile will always have the correct area. That's false. A field name area in a geodatabase will always have the correct area. That's false. Did you get them right? The ability to work with standalone tables is what gives GIS its power and flexibility. Text tables can be easily created in Notepad, but they must be tab or comma delimited. That simply means that each field is separated by either a tab or a comma. The record values are still given in rows or lines of text beneath the field headers. It is common to need to work with Excel worksheets. You should be able to sort and query the Excel files, but you can't edit them. There are some structural requirements necessary to use Excel worksheets. The first row must contain the header with less than 13 characters. Those characters are alphanumeric and can have no funny characters or symbols allowed. There can be no blank rows or formulas. It's a good idea to have the columns formatted as text or numbers. Know that ArcMap cannot open the worksheet if it's already opened in Excel. This is a good example of an acceptable worksheet structure. ArcMap can only open one worksheet from a workbook at a time, so when you add a worksheet, you need to specify which sheet has the information you want. Use the Add Data button. Browse to your Excel workbook. When you pick on the workbook, you will see the worksheets. Select the sheet you want to add to your map. You can use information from a standalone table to produce XY points. In this example, the table has latitude and longitude field. ArcMap can easily create points at those locations. Just be aware of the coordinate systems. A table with XY values can be displayed as points, but you have to know what the coordinate system is. To display XY data, right-click on the standalone table in the table of contents. Remember, standalone tables can only be seen in the source view of the table of contents. From the context menu, pick Display XY Data, select the fields containing the XY values, and specify what coordinate system. The XY display is an event and is only stored in the current map document. To use in other map projects, you should export the event into a shapefile or feature class for a geodatabase. When designing a geodatabase or attribute table, you need to understand what data you will be storing. When creating a feature class in a geodatabase or shapefile, you must decide what fields do you need or want to have in your table. Put some thought into the field type because you cannot change it. Remember the naming rules for fields. Field names must start with a letter, use only letters and numbers, and be no longer than 13 characters. Computers store all data in the form of binary numbers, zeros and ones. Combinations of zeros and ones can be used to create any number using the base 2 or binary system. ASCII is an acronym for American Standard Code for Information Interchange, which stores letters, characters, and symbols as single 7-bit binary codes. Text data will always be stored as ASCII. Numeric data can be stored as ASCII or binary, with binary being more efficient. Binary stores whole numbers, which are integers. To store decimal values, the computer uses a form of scientific notation. Float data type can store 8 significant digits, where double data types can store 16 significant digits. When designing the database storage system, the fields will be either ASCII or binary. You can also specify the bytes of storage allocated for that field and determine if the integer or floating point. Be careful to not waste storage space, but don't leave yourself short either. The largest value or number of characters that can be required in the field. Keep an understanding of these different field types and apply them as needed. Okay, let's review. Answer these questions. Which field type would be best for last name? That's easy. Text. What type would be best for the number of children in a household? I would use short. Hopefully no household has over 32,000 kids, or any households has 1/2 a kid either. Which field type would be best suited for student grade point average? In this case, I would use float. What about year of birth? Maybe the date. What about population? I would use long. I hope you got these right and have a good understanding of field types. If you have any questions, give me a call or send me an email. Thanks.